Welcome dear student and Jai Swaminarayan. In the previous video, we were discuss about the work energy theorem. And it is an important theorem. What is the work energy theorem? Work done by an external force is equal to the change in the kinetic energy. Now what do you mean by this kinetic energy? In this video we will discuss, right? Now first of all, work done by an external force. When we do some work by an external force, the work done is converted into the some form of the energy. It may be a kinetic energy, it may be a potential energy, it may be a heat energy. So to do some work, we require a energy, and work done, if we work is done on the object and work is done by an external force, and this work done is converted into the kinetic energy, or we can say that it is converted into the some form of the energy. It may be converted into the kinetic energy, it may be converted into the potential energy, it may be converted into the friction heat energy, right? Let us say one example, right? When a block is stationary on the horizontal surface, now when we applying a force, it moves in the direction of the force, so that we can say that it is in the motion, and object is in motion due to the external force, and the energy associated with the virtue of its motion is known as the kinetic energy, right? So here we can say that when we applying the force on the block lies on the horizontal surface, right, it will in the motion, and the work done on the object by an external force is converted into the kinetic energy. Now let us say one another example. When we throw an object in the upward direction, right, when we throw a ball or any object in the upward direction, so when we applying a force in the upward direction, it has some amount of the kinetic energy. So in this case, the work done by an external force is some amount of the work done is converted into the kinetic energy, some amount of the work is converted into the potential energy, and the sum of the kinetic energy and potential energy is called the mechanical energy. So dear student, in this video we will discuss about the kinetic energy, potential energy, total mechanical energy, and elastic potential energy in the spring, right? That all the thing, and some examples regarding this kinetic energy, potential energy, how we can associate the kinetic energy, how we can express the kinetic energy, that all the thing we will discuss in this video, right? So dear student, let us start with the energy. What do you mean by the energy? Energy is required to do some work. In the normal situation, we understand about the energy we require to do some work. But in this case, the energy is when the work is done on the object, this work done is converted into the form of the energy, and that state in the work energy theorem. Work done by an external force is equal to the change in the energy or change in the kinetic energy. So first of all, dear student, we understand about the kinetic energy. What is the unit of the kinetic energy? What is the dimensional formula of the kinetic energy? What is the formula of the kinetic energy? Right? So first of all is the kinetic energy. So the kinetic energy of an object is due to virtue of its motion, is due to related to its motion. When we apply an external force and any object, the object change its position. We can say that the rest object are in the motion, and due to this virtue of its motion, the energy associated with the object is called the kinetic energy. So when the any object is in the motion, the some amount of the kinetic energy is associated with the object. So what is the kinetic energy? When the object is stationary, right, that means it lies stationary on the any surface, we can say that the velocity of the object is zero, and the kinetic energy associated with the object is zero, right? but when the object is in the motion, it has some amount of the kinetic energy. So here the definition of the kinetic energy is important. What is the kinetic energy? The kinetic energy is defined as the half of the product of mass and the square of the velocity, right? So the formula of the kinetic energy is K is equal to kinetic energy, K is equal to 1 half mv square, where m is the mass of the object, v is the velocity of the object. So here the kinetic energy is defined as the half of the product of mass and the square of the velocity. Energy associated with the object due to virtue of its motion is called the kinetic energy. Here, dear student, the formula of the kinetic energy, when the object of a mass m moving with the velocity v, the kinetic energy k is equal to 1 half mv square. When the object is stationary, we can say that the velocity of the object is 0 and the kinetic energy associated with the object is also 0. Dear student, here the kinetic energy is a scalar quantity, right? So kinetic energy is a scalar quantity and the unit of the kinetic energy is joule, right? So another unit of the kinetic energy, larger unit, kilojoule, megajoule, electron volt is also a unit of the energy that we will see later on, right? So here the kinetic energy is defined as the half of the product of mass and the square of the velocity. Kinetic energy K is equal to 1 half mv square. The unit of the kinetic energy is joule. We can easily find the dimensional formula of the kinetic energy by placing a dimensional formula of the mass and dimensional formula of the velocity square and can evaluate the dimensional formula of the kinetic energy. So understand, dear student, what do you mean by the kinetic energy? Kinetic energy K is equal to 1 half mv square. So you can easily work. If the object of a mass 2 kg is moving with the speed of a 20 meter per second, calculate the kinetic energy associated with the object. You can sorry, you can usually calculate with the help of this formula, right? Mass of the object is a 2 kg, velocity is a 20 meter per second, speed is a 20 meter per second. So put the value and you can easily find the kinetic energy. If the person is moving, a person having a mass 60 kg is moving with the speed of the 10 kilometer per hour, you can easily calculate the energy associated with this person, right? Now what is the how the kinetic energy is related to the momentum, because we can say that if the object is in the motion, it has some amount of the momentum, it has some amount of the kinetic energy. So what is the relation between the kinetic energy and the momentum of the object, or we can say that the linear momentum of the object. So here we know that if the object of the mass m moving with the velocity v, kinetic energy K is equal to 1 half mv square and the momentum of the object P is equal to mv, right? So kinetic energy K is equal to 1 half mv square and momentum P is equal to m into v, right? So P is equal to mv. From this, take a v is equal to P divided by m and put in this formula. So we get a K is equal to 1 half m into P square by m square. One cut out and we get the relation between the kinetic energy and the linear momentum. So kinetic energy K is equal to P square divided by twice m. Kinetic energy is directly proportional to the square of the linear momentum of the object. So this question is important for the exam also. Define the kinetic energy and derive the relation between the kinetic energy and the linear momentum. Understand? So now dear student, let us take a one example. Example 6.2 of the textbook. So let us see the sentence of the example number 6.2 of the textbook on the page number 116. Right? Page number 116, example 6.2 is given to you. It is well known that a raindrop falls under the influence of the downward gravitational force and the opposing resistive force. Here the raindrop fall down in the downward direction under the influence of the two different forces. First one force is a gravitational force. It is in the downward direction, and the resistive force, it is in the opposite to the motion of the raindrop. The latter is known to be proportional to the speed of the drop, but it is otherwise undetermined. Consider a drop of a mass 1 gram falling from the height 1 kilometer. It hits the ground with the speed of the 50 meter per second. So here the mass of the raindrop is given to you 1 gram, right? It is falling from a height 1 kilometer. It hits the ground with the speed of the 50 meter per second. Now what is the work done by the gravitational force and what is the work done by the unknown resistive force? Now here according to the work energy theorem, we know that work done by the gravitational force, it is equal to the change in the kinetic energy. So initially the raindrop is stationary at a height 1 kilometer, right? And finally when it hits the ground, the speed of the raindrop is a 50 meter per second. So it has a some amount of the kinetic energy. So work done, it is equal to the change in the kinetic energy. We can see that the work done by the gravitational force is equal to the change in the kinetic energy of the drop. Delta K is equal to 1 half mv square, that is the final kinetic energy, minus 0, that is the initial kinetic energy. So we can calculate 1 half mass of the raindrop is a 1 gram, that is a 10 raised to minus 3 kg, into speed of the raindrop is a 50 meter per second, 50 into 50. So the change in the kinetic energy is a delta K 1.25 joule. Similarly, the work done, it is equal to the change in the kinetic energy. So we can easily calculate work done W is equal to 1.25 joule, right? So now here work done is equal to 25 joule. Now work done due to the gravitational force, Wg is equal to mgh. M is the mass of the raindrop, 10 raised to minus 3. G gravitational acceleration, we take a 10 meter per second, and h is the height, that is the 1000, right? So from that you can easily calculate 10 raised to 3000, that means a 10 raised to 3. So work done by a gravitational force Wg is equal to 10 joule. Now according to the work energy theorem, the change in the kinetic energy is equal to work done by the gravitational force and work done by the resistive force. So from this formula you can easily calculate the work done by a resistive force, and work done by a resistive force is a negative. Change in the kinetic energy 1.25 minus work done by the gravitational force is a 10 joule. So 1.25 minus 10, you get answer minus 8.75 joule. So work done by a resistive force is a negative because the resistive force and the motion of the object is opposite, right? So dear student, understand the example number 6.2. Mass of the raindrop is given to you 1 gram. We need to convert into the kilogram, 10 raised to minus 3 kilogram. Height from which the raindrop falls 1 kilometer is equal to 1000 meter, right? And the speed when the raindrop hits the ground is a 50 meter per second. Take a G is equal to 10 meter per second square. So we need to find the work done by a resistive force and work done by a gravitational force. So work done by a resistive force, or we can say first find the change in the kinetic energy. Change in the kinetic energy is equal to 1 half mv square minus 0, because the initial kinetic energy is 0. Initially raindrop is stationary, and we can say that the initial kinetic energy is 0, right? So kinetic energy, change in the kinetic energy is a 1.25 joule. Now work done by a gravitational force is equal to mgh, m mass of the object 10 raised to minus 3 into g10 and h 1000 meter. So work done by a gravitational force is a 10 joule. So according to the work energy theorem, change in the kinetic energy is equal to work done, because here work done by a gravitational force plus work done by a resistive force. So work done by a resistive force delta K minus Wg, you can find the minus 8.75 joule, and it is a negative. Why it is negative? So work done by a resistive force is a negative because the resistive force and the motion of the object is in the opposite direction, and when the force and the displacement is in the opposite direction, the work is a negative. Understand? Now example number 6.3 of the textbook. Let us see the sentence of the example number 6.3. Yes. A cyclist come to the skidding stop in 10 meter. During this process, the force on the cycle due to the road is 200 Newton and directly opposed to the motion. How much work does the road do on the cycle, and how much work does the cycle do on the road? So when the force, here the cyclist comes to a skidding to stop at 10 meter. That means the displacement is a 10 meter. Here the force applied on the cycle due to road is a 200 Newton, right? So work done on the road due to cycle and work done on the cycle due to road we need to find, right? So here let us see the answer of this, how we can find the work done. Work done, formula of the work done is equal to W is equal to F dot D, right? So in the first situation, the force on the cycle due to road, work done on the cycle due to road, here the displacement is at 10 meter, right? The force on the cycle due to road F is equal to 200 Newton. So when the cyclist is skidding, the angle between displacement and the force applied on the cyclist is in the opposite direction to the displacement, right? So W is equal to FD cos theta. Here the angle between the force and displacement, because the displacement of the cycle is in the forward direction and the resistive force applied on the cycle by a brake is in the opposite direction. So angle between the force and displacement is 180. So W is equal to FD cos 180. F force 200 into displacement 10 meter cos 180. Value of cos 180 is a minus 1. So we get a work done on the cycle due to road is a minus 2000 joule. Now force on the road by a cycle. According to the Newton's third law, the force applied on the cycle by a road is same as the force applied on the road by a cycle, but in the opposite direction. So F is equal to minus 200 Newton. But due to this, the road cannot displace so that the displacement of the road is 0. So we can say that the work done is a 0. Now we will see example number 6.4. Textbook solve example 6.4. Let us see the sentence of the example 6.4. In a ballast demonstration, a police officer fires a bullet of a mass 50 gram with a speed 200 meter per second. So here the mass of the bullet is a 50 gram. We need to convert into the kg. So 50 into 10 raised to minus 3 kg. With a speed of the bullet is a 200 meter per second. On soft plywood of a thickness 2 centimeter. Thickness of the plywood is given to you 2 centimeter. We need to convert into the meter. 2 into 10 raised to minus 2 meter. The bullet emerged with only 10% of its initial kinetic energy. What is the emergent speed of the bullet? So here we need to find the emergent speed of the bullet. That means the final speed of the bullet. final initial velocity of the bullet is 200 meter per second. So you can easily calculate the uh, initial kinetic energy from this 1 half mv square, right? Then in the thickness 2 centimeter, so we need to calculate the work done, and change in the kinetic energy is equal to the work done. From that we can find the final kinetic energy, and from the final kinetic energy we can find the final speed, that means the emergent speed of the bullet, right? So here the mass of the bullet is a 50 gram, that is the 50 divided by 1000 kg, 0.05 kg. Speed of the bullet, that is the initial speed of the bullet, Vi is equal to 200 meter per second. Thickness of the plywood sheet, x is equal to 2 centimeter, that is the 2 into 10 raised to minus 2 meter, or we can say that 0.02 meter, right? Now from that we can find the initial kinetic energy. So initial kinetic energy Ki is equal to 1 half mvi square. 1 half m, mass of the bullet 0.05 kg, and initial speed 200 meter per second, 200 square. We get the initial kinetic energy is 100 joule. Now in the sentence given to you, only 10% of initial velocity. The bullet emerges with the only 10% of the initial velocity. So here we need to calculate final kinetic energy, that is the 10% of the initial kinetic energy. So final kinetic energy Kf is equal to 10% of the initial kinetic energy Ki. So 10%, that means the 10 divided by 100 into initial kinetic energy 1000 joule. So we get the final kinetic energy Kp is equal to 100 joule. Now from the equation of the kinetic energy Kf is equal to 1 half mvf square, we can easily calculate Vf is equal to under root of 2 into Kf divided by m. So under root of 2 into 100 divided by 0.05. So if you calculate that, we get the final velocity of the bullet or emergent speed of the bullet in the plywood is a Vf is equal to 63.24 meter per second. Understand this example? So here similar example is given in the exercise 6.12. Let us see the statement of the example. Exercise 6.12. An electron and proton are detected in a cosmic ray experiment. The first with the kinetic energy 10 kilo electron volt and second with the energy 100 kilo electron volt. So kinetic energy of the electron is a 10 kilo electron volt, and kinetic energy of the proton is a 100 kilo electron volt. Which is faster, the electron or the proton? Obtain the ratio of their speed. The mass of the electron 9.11 into 10 raised to minus 31, and mass of the proton is a 1.67 into 10 raised to minus 27 kg. And here we need to convert this electron volt, which is the unit of the energy, into joule. So 1 electron volt is equal to 1.6 into 10 raised to minus 19 joule. So here the electron volt is also a unit of the energy, and 1 electron volt is equal to 1.6 into 10 raised to minus 19 joule. So here the electron and proton is given to you. Kinetic energy of the electron is 10 kilo electron volt, and kinetic energy of the proton is 100 kilo electron volt. 1 electron volt is equal to 1.6 into 10 raised to minus 19 joule. Which one is faster? So we need to find the speed of the electron and the speed of the proton. So from the equation of kinetic energy of electron, K is equal to 10 kilo electron volt. So kilo, that means 10 raised to 3 electron volt. So 10 into 10 raised to 3 electron volt. Now electron volt, how we convert electron volt into joule? 1 electron volt is equal to 1.6 into 10 raised to minus 19 joule. So 10 into 10 raised to 3 into 1.6 into 10 raised to minus 19 joule. That is the kinetic energy of electron. Similarly, you calculate the kinetic energy of proton, right? So kinetic energy of proton 100 kilo electron volt, 100 into 10 raised to 3 electron volt, 100 into 10 raised to 3 into 1.6 into 10 raised to minus 19 joule. Now, kinetic energy K is equal to 1 half MeVe square, 1 half mv square, E for electron. So, from that, speed of the electron ve is equal to under root of 2ke divided by me. So 2ke, kinetic energy of electron, 10 raised to 3 into 1.6 into 10 raised to minus 19 into 2 divided by 9.1 into 10 raised to minus 31. So calculate this speed of the electron, similarly calculate the speed of the proton, and from that you can find which one is faster, electron or proton, and find the ratio of the speed of the electron to the speed of the proton. Understand? Now dear student, we will discuss the another type of the energy, potential energy. So kinetic energy, energy is due to the virtue of its motion. Another energy, potential energy, is an energy associated with the object due to the position or the configuration of the object. So due to the position of the object, the energy associated with the object is called the potential energy. Potential energy. There are two types of the potential energy: gravitational potential energy and the elastic potential energy. Gravitational potential energy associated with the position of the object on the earth's gravitational field, right? And elastic potential energy is energy associated with the elasticity property of the material, right? So the potential energy is denoted by capital U or capital V. In the some textbook you will find the notation of the potential energy capital U, and in the some textbook you will find the notation of the potential energy is capital V. So first of all, first one is the gravitational potential energy. So when the object taking of the some height from the surface of the earth, we require to do work done against the gravitational force. So dear student, whenever we throw an object in the upward direction, or whenever we taking a object uh, from the earth surface to the some height, we require to do against work done against the gravitational force, and this work stored in the form of the potential energy, and this potential energy is known as the gravitational potential energy. So understand dear student, what do you mean by the gravitational potential energy? When the object taking of a some height from the surface of the earth, we require to do a work against the gravitational force, and the work done required to do to take the object from the surface of the earth to the some height is stored in the form of the potential energy, and this potential energy is known as the gravitational potential energy. Let us consider an object having a mass m is lifted at a height h. So on the surface of the earth we have a object of a mass m. Now we want to lift this object at a height h. There are so many paths to lift the object at a height h. One way is a straight path, right? Another way is like this type of the zigzag path. So we can take any path to lift the object of at a height h, right? And in all the paths the work done remains same, that we will see later on, right? So work done to lift the object at a height h does not depends on the path, right? So work done required to move the object at a height h against the gravitational force. What is the formula of the work done? Yes, W is equal to force into displacement. So here the force and the displacement are in the opposite direction, because the gravitational force is in the downward direction and the displacement is in the upward direction, right? So we take the work done is the FD cos 180, that is the A minus FD. So F is a gravitational force. Gravitational force, what is the gravitational force? W is equal to m into g. So put the value of F is the m in g. We get the work done against the gravitational force. W is equal to minus mgl. So dear student, the gravitational potential energy at the height h, Vh, or we can say that the U is equal to mgh. and the change in the potential energy. We consider potential energy on the surface of the earth is a zero. So if we leave the object at a height h, the change in the potential energy is equal to final potential energy, that is the mgh minus 0. So change in the potential energy is delta u is equal to mgh. Why? Because at the surface of the earth we take the potential energy 0. Right? Understand, dear student? So now take this some short question. Calculate the work done required to lift an object of a mass m, mass 5 kg at a height 15 meter. So here the mass of the object 5 kg is given to you. Height h is equal to 50 meter and g is equal to 9.8 or 10 meter per second square. You can easily calculate work done as well as the change in the potential energy of the object. U is equal to mgh or W is equal to mgh. You can easily calculate. So calculate this example short question by yourself. Now dear student, when we throw an object in the upward direction with the some amount of the force, right, we have to work against the gravitational force. So when we applying a force on the object and object moves in the upward direction, right, so the work done by an external force applied on the object is converted into the kinetic energy. So kinetic energy equation, you know that, right? So this kinetic, as the object is moving in the upward direction, its a kinetic energy is decreases, but potential energy is increases. So kinetic energy is changed, potential energy is changed, right? So we can say that delta K, change in the kinetic energy, is equal to the change in the potential energy. We can write like this also, 1 half mv square is equal to mgl, and that is the most important formula of the kinetic energy and the potential energy. So as the kinetic energy of the object changes, as the object is moving in the upward direction, the kinetic energy of the object changes, same as the potential energy of the object changes, and the change in the kinetic energy is equal to change in the potential energy. So at the ground surface of the earth, we consider that the kinetic energy is a maximum, right, 1 half mv square, and potential energy is 0. So as the object is moving upward direction, the kinetic energy is decreases and the potential energy is increases. At the maximum height, the kinetic energy becomes 0. So the speed of the object becomes 0, whereas the potential energy is maximum. So from that, we can say that the sum of the change in the kinetic energy is equal to the change in the potential energy. So we can say that 1 half mv square is equal to mgh, right? And sum of the kinetic energy and the potential energy, it does not change with the time, and that is called the total mechanical energy, right? The sum of the kinetic energy and the potential energy is called the mechanical energy. And as the object is thrown, moves in the upward direction, kinetic energy may change, potential energy may change, but the sum of the kinetic energy and potential energy remains constant, and that is called the law of conservation of mechanical energy. So mechanical energy E is equal to K plus U. So change in the mechanical energy, delta E is equal to delta K plus delta U, right? But here the kinetic energy may be changed, potential energy may change, but the total mechanical energy remains constant. So change in the mechanical energy delta E, we take a 0, is equal to delta K plus delta U, right? So delta K is equal to minus delta U. So this minus sign indicates that the change in the kinetic energy and potential energy is opposite. Here the kinetic energy is decreased, the potential energy is increased, and if the potential energy is decreased, the kinetic energy is increased. So from that, work energy theorem can be modified like this: the work done by an external force is equal to change in the kinetic energy, and it is equal to the change in the potential energy. You must have to remember this statement for the example also, right? Work done by an external force is equal to the change in the kinetic energy is equal to the change in the potential energy, and this statement is known as the work energy theorem. So now we will see last point about the kinetic energy and potential energy. As previously we were discussed about, as the object is moving in the upward direction, the potential energy maybe is increases, right? So work is required to do against the gravitational force, and the work done against the gravitational force does not depends on the path, and this property is called the conservative property, and the force is called the conservative force. So work done against the gravitational force does not depends on the path. So this property is called the conservative property, and the gravitational force is called the conservative force. So by applying a force, the F, the potential energy changes by delta U, right? So we can say that work done against the force. Suppose the object M is moving at a height h, right? So the work done W is equal to F into delta x, right? Again, according to the work energy theorem, work done is equal to change in the potential energy. So F delta x is equal to minus delta U. So from that, the conservative force F is equal to minus delta V delta U by delta x. Or if we consider the small limit delta x tends to 0, infinitesimally small displacement, the conservative force F is written as a minus du by dx, right? Understand, dear student, this all the points.